All right, we're going to talk about volume of prisms and cylinders. And once again, there's a couple vocabulary words. Make sure you get those in your notes, and if you don't have them in there, stop the tape and go ahead and put those in there. All right, we're back in Google SketchUp because I want to use it to kind of talk about volume again. And when we talk about volume, what I want you to understand is that everything started as a two-dimensional object. So I've drawn some two-dimensional objects here. I've got a rectangle, I've got a triangle, I've got a circle, and all of those started as two-dimensional objects, and they have their own formula. So for instance, for the rectangle, it's base times height. For the triangle, it's 1/2 base times height. And for the circle, it's pi r squared. Those give you the area of that two-dimensional surface. And the only difference between what we have right now and what we have when I pull that up is the height. All I've added is some height to this object, so it now has a third dimension. So when we're trying to figure out, well, what's the formula? If we knew that the formula for that rectangle was base times height, or yeah, base times height, what we're talking about, or length times width, actually would be better, length times width. Now the only thing I've had added to this is my height, and so that's the third dimension. So let's think about this triangle. So here I've got this triangle. We know that if I take 1/2 of the length of the bottom side, the base, times the height, then I get the area of that triangle. And then we're going to add in, and this, we're kind of adding in a third or a second height. It's not, this is my third dimension here as I pull it up. So as long as I can find the area right along there, that length there, I know the area from the bottom to the top there, I can take 1/2 times those two things plus how high did I pull it up. That is how I figure out the formula of a three-dimensional object, of that triangular prism that I have right there. Or if I'm talking about a circle, here I have a circle right here. Let's move this so we can see this a little bit better and kind of rearrange our things there. So I've got my circle, and remember that's pi r squared, and all I'm going to do now is make it taller. So my cylinder is simply pi r squared times the height that I pulled it up. So I just want to show you that these are really pretty simple. There's just one more dimension. It's just how tall is it? Everything is, take my normal base that I had, and then how tall is it? And that's how I figure out what my formula is, or how I figure out my volume. And when we do volume, we're talking about cubic whatever, cubic meters, cubic feet, or whatever. All right, I hope that little bit with SketchUp kind of helps you kind of visualize some of this, because for me, when I was younger, I didn't really think about three-dimensional objects this way. I didn't think about prisms and stuff when trying to find the areas, and I didn't think about it like that. So I'm hoping that helps you out just a little bit. When we're talking about volume, normally we're going to be in cubic units, cubic inches or cubic feet or cubic meters or something like that. It's going to be pretty common. Now, the way that your book talks about it, and this gets a little bit confusing as we talk about base, and we had bases when we were talking about triangles, and now we have bases again. We're talking here. I do believe they try to distinguish that by making it with a capital B for the base. And what they're saying is this is basically what I said too. If you can find the area of the base, of that original starting object in the two dimensions, and then you figure out how high it went, you can now find the volume. That's really all you need to do. So if we have a rectangular prism, we find the area of the rectangle. If we have a triangular prism, we find the area of the rectangle. And from that, we can figure out the volume. So if we take a look at this first example, it's 5 centimeters by 9 centimeters by 6.5. And if we think of it as, what is this rectangular area down here, 5 times 9 or 45, and then the height is 6.5. So then you take that times 6.5. Now, for something as simple as a rectangular prism, you may just remember length times width times height, and there's nothing wrong with that either. But the nice thing about keeping in mind base times height is it works for rectangular, triangular, pentagon, any shape. It works. As long as you find the base, you can take it times the height, it works. It even works for cylinders where we're talking about a circle, and we take that up. Anyway, 45 times 6.5, if you multiply all that out, you get 292.5. And here's a second one. And here we've got a triangular prism, as you can see. So I've got, it's 6 inches along here. This altitude, I guess, if you want to call that, would be 7 inches. So that's going to be 1/2 times 6 times 7. 1/2 times 6 is 3 times 7 gives me 21. And then I got to give it this dimension here. So times 10. And that equals 210. And it is 3 dimensions, so this one would be cubic inches. If we're talking about a cylinder, we find the base of the cylinder, that is the circle, and then we find what the height is, and we can multiply those two things together. And of course, we know that base times height, or the circle itself rather, is pi r squared. So we've got our still our original formula, same thing we had, base times height for any of these three-dimensional objects. What is capital B base? That's pi r squared. So my total volume would be pi r squared times the height of that object. So let's take a look at an example here. It says find the volume of this cylinder. So we know that the radius is 6 feet. This is my height. So I can do pi r squared to find the circle. So pi is 3.14 times 6 squared, or 36, and then take that times the 20, and I end up with 2,261.9. And once again, these are always going to be, whenever we're dealing with pi, these are going to be approximations, and so I would just normally round off to the nearest tenth. Round that off correctly. Okay, number 4 says, let's say we've got a base. Diameter of the base is 13 meters, and the height is 15.2. So we don't have a drawing, but we don't need a drawing, because we know that we're talking about a cylinder here, and we know that the diameter is 13 meters. So let's make our own. We know that all the way across the circle is 13 meters. But we don't want the all the way across, we want halfway, we want the radius, and that would be 6.5. So let's replace all that, and we would get 3.14 times our radius, 6.5 squared, times the height of 15.2, and when we multiply this out, we're in meters here, so we would get cubic meters, 2,017.5 cubic meters. All right, guess what? It's your turn. You do these problems, write them in your notes. They need to be in your notes, and I will take a look at those. We'll come back to those in just a little bit. All right, for A, rectangular ones, those are really, really simple. We can just take 3 times 13 times 8.5, and when we're all said and done, we should get 331.5 cubic inches. On the triangular ones, we're going to take this part, we're going to take the triangle part, and we're going to only take half of that, because triangles are 1/2 base times height. And so we're going to take 1/2 times 8 times 5, which would be 20. And then we're going to take that times the length here, or the height of it actually for standing up, times 12, and that's going to give us, what is that, 240. And we are cubic millimeters. For my circle, pi r squared, so it's pi times 2 squared times 7. And when I put that into the calculator, I get about 88.0 cubic inches. A couple chapters back, we talked about complex figures, and we talked about the way to do that was to break them down into ones that we knew. Well, here we're going to talk about some complex solids. And once again, I mean, this is pretty normal. You're going to see objects that are not just, you know, one object in there. It's going to be maybe two objects or maybe more put together. So here's an example. This is a soap container like you would see in the bathroom. And it is created from two three-dimensional objects, two prisms, a rectangular prism and a triangular prism. So I've got my rectangular prism here. I've got my triangular prism up here. And so we're going to break that down into these two separate ones. So here's my rectangular prism. It is 5 by 7. And so that's my base. It is also 5. They don't have it down there, but it's 5 inches high. And so the rectangle on the bottom, 5 by 7, we'll do that off the side here. 5 by 7 is going to be 35 times another 5 for the height. That's this height right here. So times 5, and that's going to give you 175 for the volume there. And we're talking about cubic inches. And this one right here, we've got a triangle. And so if we figure out what the triangular part of this is, and I don't know why they gave me some of this, because I need this 3 over here to figure out my triangle. So this, let's write that in here. This would be 3 inches right here. And so to figure out the triangle is 1/2 times the length of this base, 7, times the height of 3, and it is 5 inches wide, so times 5. And that would be 52.5. Add that into over here, 52.5. And we get 0.572, 227.5 cubic inches for our soap dispenser. Okay, so what I would like you to do now, let's just do I think we need just a little bit more practice on this. So on page 337, would you please do numbers 5, 6, and 7? 5, 6, and 7 on page 337, and show those to me. That will be part of your notes.